The final thing that I'd like to talk about is likelihood. Likelihood is the math that we use to measure how good a job a model does in explaining the relationship between our input data and our output data. So when you have a model, that's a mathematical description of what you think is going on. And you can use that to compute the probability of some data. So you say, here's my model. Based on that model, what's the probability that I observe these data? So for example, a fair coin is a model that's saying there's a uniform distribution a discrete uniform distribution with two outcomes. And so then we can say what's the probability of observing data, 4 flips with 4 heads, given our model. So here's our model. Probability of heads is 0.5. Data, 4 heads, 0 tails. So that means total sample size of 4, and number of heads observed is also 4. So this is the way a casino owner would look at probability, right? They know how their games work, they know the mechanism of their machines, and they want to calculate the probability of each outcome so that they don't, pay too much for common outcomes. But they pay enough for rare outcomes to keep people coming. So let's talk about a little bit more concrete example. So we have smartphones and iPhones in particular. So according to a website I visited last year, about 20% of all smartphones are iPhones. And according to a survey that I did of my students last year, about 77 of the 87 students in the course have iPhones. So sometimes this is where we get our model. We get our model from previous research. So our model here is the probability of owning an iPhone is 20%, or 0.2. And the data that we have is that 77 of our 87 students own iPhones. So we can use our model to compute the probability of observing that. It's a binomial distribution. And that number, which is, basically 0, is the probability of observing these data given this model. So we could say that these data are not very probable given this model. So the logical thing to say is that 87 smartphone users from around the world might have, something like 14 smartphone users. But 77 is just really unlikely. So we would say that seems like Carthage students are not coming from the same population that is all worldwide cell phone users. They're a subset of that population that has specific characteristics. They're probably people from more affluent circumstances, and there's a certain drive to own iPhones to be able to work with some of the technology for our classes. So that means we should probably make a different model, one that more closely reflects our Carthage students. In this case, we would have the same probability model, iPhone or not an iPhone. That's a Bernoulli process, but we look for a different parameterization, one that better reflects the actual number of students we have with iPhones. And so we're going to use likelihood to calculate that. So when you have data and you want to compare different models and see which models are good matches of that data, then you use likelihood. We talk about the likelihood of a model given the data, and that's why we talked about conditional probability. So if you have flipped a coin 4 times and gotten 4 heads, the likelihood that it's a fair coin is, we have the data there and the model there, and that would be 1.5 to the 4th, or what is that? That's 1/16. So the likelihood of that model is 1/16. And so this is the scientist's point of view. We know the data. The data aren't what we're wondering about, but we don't know about how the world works. We're trying to make our best guess about how the world works. So if we look at likelihood of 77, that this 20% model is a good model for Carthage students, we see this thing that's very close to 0. In other words, it's very unlikely that Carthage students are represented in the global population of smartphone users. Now, if you're paying attention, you'll see that those two slides used exactly the same math. And that's not a coincidence. Probability and likelihood use the same math. They just look at what thing is fixed and what thing we're estimating differently. So with probability, we have a fixed model. We know the process, and we can compute the probability of observing a particular combination of results given that known process. With likelihood, we have a known outcome. We have observed a bunch of things, and then we're trying to decide which model, oftentimes which parameterization of the model, is the best fit to the data that we see. So models with higher likelihoods are better fits to the data. Models with lower likelihoods are worse fits to data. And we will talk about how we compute some of that stuff on Thursday. So, no, Thursday is about to happen next Tuesday. All right, I finished embarrassing myself for this evening. I hope that you are less confused than you were before, and you have questions tomorrow.